Welcome to the first videotape of your Algebra 2 Trig year. We're going to start with Chapter 1 today, and you should have your Chapter 1 notes that I gave you in class in front of you with a pen, and we're going to go through these guided notes and fill in the blanks. And you can just listen and follow along with me. And then tomorrow when you get into class, we will apply all of the concepts that are in these first three pages of this Chapter 1 set of notes. We're going to talk about something that you've already done before called absolute value. You've probably done or had absolute value mentioned for a few years, and what we're going to do with absolute value today is we're going to solve some equations that have absolute values in them. And if you can remember that the absolute value is just a distance from zero oftentimes we say the distance from zero like on a number line, and it's always positive because when you talk about distance, you always talk about a positive number, either positive or the absolute value of zero is zero. So it's a non-negative number. So the distance from zero, which is never negative, because distances can't be negative ever. Now the notation for absolute value, you remember, is just two vertical lines, and you can see some absolute values below here. The absolute value of -7 is a distance of 7 from 0. The absolute value of 7 is a distance of 7. So what you're really doing is taking what's inside here and making it positive. And so with these two equations, you can see that if you're going to put a variable inside the absolute value, if the absolute value of x is 7, then x could be really two different numbers. It could be -7, like in this first situation, or it could be +7, like in the second situation. So in general, if you have the absolute value of some expression here, x is a variable like 3x plus 1, and if this value of c, it must be greater than or equal to 0, should probably put an equal to in here, then ax plus b is either equal to the opposite of c, or ax plus b is equal to c. Just like we set up here, you take the opposite of this number, or you take the positive value of this number. So what we're going to do is we're going to have some absolute value equations to solve, and you should have solved these back in Algebra 1 if you remember that long ago. But there's really just basically three steps to solving them. First of all, you're going to isolate. Isolate means get it by itself. Isolate the absolute value portion of the equation, and I'll go through these with some examples. And then step 2 is you just drop the absolute value symbols. That just means you get rid of them. And then you're going to write two separate equations. First of all, whatever's inside, you're going to set it equal to negative, and then you're going to set it equal to the positive value of whatever's on the right-hand side of the equation. So what that really means is leave what is inside the absolute value symbols alone. Don't ever change signs or whatever's inside the absolute value symbols. You just leave those alone. So once you get done with that, you're going to have two different equations, and you're going to solve each one individually. So you get two answers, and you have to check both answers back into the original equation to make sure that they're checking okay. So the best way to see these steps is with the example. What if we have the absolute value of 3x minus 7 set equal to 10? Well, what you're going to do, and what I like to see in your homework, or what you're going to do in class, is I want to see you draw two lines. You're going to have a left-hand branch and a right-hand branch. In the left-hand branch, you're just going to take this 10 and make it a -10. And then over on the right-hand side, you're just going to keep it equal to the positive 10. So you have two equations to solve, and there's an or in between them because you're going to have two different answers, one or the other. So in order to solve this, you're going to add 7 to both sides. And so you're going to get 3x equal to -10 plus 7 is -3. And then you're going to divide both sides by 3. So the 3's cancel out, and you get x is equal to -3 over 3, which is -1. So there's one of the answers. You box it in. Or over here, when you add 7 to both sides, 10 plus 7 is 17. They cancel, so you get 3x equals 17, and when you divide both sides by 3, the 3's cancel out, and you're going to get x equal to 17 over 3, and just leave it like that as an improper fraction. Don't change it into a decimal. It's not necessary. So what we're going to do next is we're going to check to make sure that each one of these are work in the original equation. So the original equation up here is the absolute value of 3x minus 7 equals 10. So what we're going to do is we're going to substitute a negative 1 in for that x. We're going to say, let's let x equal negative 1. So we're going to have the absolute value of 3 times negative 1 minus 7. Does that equal 10? Well, the absolute value, 3 times negative 1 is negative 3. Negative 3 minus 7 is equal to negative 10. And the absolute value of negative 10 is 10. And 10 equals 10, so that checks. So we've got x equals negative 1 is our first answer. Or, now we're going to check our other answer. We're going to check x equals 17 over 3. So we're going to start with the original equation again. 3x minus 7 equals 10. And now we're going to substitute a 17 over 3 in here. So 3 times 17 over 3 minus 7, does that equal 10? Well, if you want to get your calculators out, you can, but 3 times 17 over 3, those 3's are going to cancel, and you're just going to be left with 17 minus 7. Make those absolute values signs a little bit taller than the ones. And 17 minus 7 is 10, and the absolute value of 10 is 10, and 10 equals 10, so that checks. So negative 1 is one of the answers, and 17 over 3 is the other answer. So you have 2 answers to this problem. Going on to page 2, these are just 3 examples, and we're going to solve these. If you want to shut off the video and try to solve these on your own, that's fine. That might be a good way to practice this to make sure you understand it, or if you just want to go through all of these, you want to go through one with me and then 2 on your own and see what you get, that would be fine. But let's do these next 3. First of all, we have to isolate the absolute value symbol, which means we have to add 4 to both sides first. Don't forget that the first step is to isolate the absolute value. That's step 1. That means getting rid of this minus 4 over here. So that means you're going to be left with the absolute value 5x minus 10 is equal to 11 plus 4, which is 15. So now what we're going to do is we're going to do a left-hand branch and a right-hand branch like we did on the other page. We're going to create 2 equations. The first one says 5x minus 10 equals negative 15. And over on the right-hand side, it's going to say 5x minus 10 equals positive 15. Just get rid of the absolute values and have a negative and a positive. So then we go ahead and solve this by adding 10 to both sides. They cancel, and you get 5x equals negative 5. And dividing both sides by 5, you get x equals negative 1. So there's one of the answers. Or, I should have put an or up here, or now you're going to add 10 to 15. And you're going to get 5x is equal to 25. And when you divide both sides by 5, you're going to get x is equal to 5. So you have 2 answers, negative 1 or 5. And then we have to check our answers to make sure they're okay. So let's just put a check over here. And we're going to check x equals negative 1 first, but you have to check in the original equation. So it's 5x minus 10, absolute value, minus 4 equals 11. So let's check x equals negative 1 first. So 5 times negative 1 minus 10 minus 4, does that equal 11? This is negative 5 minus 10 minus 4, does that equal 11? This says the absolute value of negative 5 minus 10 is negative 15. And the absolute value of negative 15 is positive 15. So does 15 minus 4 equal 11? Well, yes, 11 equals 11. So there's your first check. Now sometimes they don't check, so it's really important that you check both. So we're going to say check x equals negative 1 first. Now let's check On the other side, let's check x equals positive 5. So you start out with the original equation, absolute value 5x minus 10 minus 4 equals 11. Now you're going to substitute a 5. And now you're going to substitute x equals 5 in. So you have the absolute value of 5 times 5 minus 10. And minus 4 equals 11. 5 times 5 is 25. 25 minus 10 is 15. Absolute value 15 is 15, so 15 minus 4 equals 11, and that is a true statement. 11 equals 11, so that one checks also. So now you have two solutions here. X is equal to negative 1 or X is equal to 5. Down here on the second example, the absolute value is already isolated, so you don't have to go through that first step of isolating like up there. All you have to do is write out 1/2 x minus 10 is equal to negative 30, or 1/2 x minus 10 is equal to positive 30. And go ahead and solve that by adding 10 to both sides, and you have 1/2 x, 10's cancel out, equals negative 20. Now to get rid of a fraction coefficient, you're not going to divide both sides by 1/2 like you divide by an integer. What you're going to do is you're going to multiply both sides by the reciprocal of this fraction. So the reciprocal of 1/2 is 2 over 1, or 2. So you're just going to multiply both sides by 2 because that makes those 2's cancel, and you're going to just get left with x is equal to negative 20 times 2, which is negative 40. So there's one potential answer. And then over here, when you add 10 to 30, you're going to get 1/2 x is equal to 40. And now instead, like I said, of dividing both sides by 1/2, you're going to multiply by the reciprocal, which is just 2. And 2 times 1/2 is just 1, so 1x is equal to 80. So you have two potential answers here, negative 40 and 80. So now, when you check this into the original, remember it's the original equation that you check it into. Let's check x equals negative 40 first. So we'll write this as a check, or our checks. So does the absolute value of 1/2 times negative 40 minus 10 equal 30? Absolute value, 1/2 times negative 40 is negative 20. Negative 20 minus 10 is negative 30, absolute value. And does the absolute value of negative 30? Yes, 30 equals 30, so that one checks. So x equals negative 40 is one answer. So now you're going to check x equals 80 into the original equation. So 1/2 times 80, absolute value, minus 10, does that equal 30? Well, 1/2 of 80 is 40. 40 minus 10, whoops, can't write tonight, equals 30. Now 40 minus 10 is 30, so does the absolute value of 30 equal 30? Well, yes, 30 does equal 30, so you have two answers, x equals 40 or x equals 80. Oops, kind of got off the page here. So 40 minus 10. So if you didn't get a chance to figure this out while I was talking, that's what it looks like. And now this last example on the page, you do have to isolate the absolute value first because you've got this minus 4 over here along with this absolute value of x. So to isolate that, you're going to add 4 to both sides to get rid of that minus 4. So that gives you the absolute value of x is equal to 3x plus 4. Now this one is a little trickier than the other ones because when you take the left-hand branch, you're going to negate this whole expression over here. So this is going to say x is equal to negative 3x minus 4. Every term gets negated on the left-hand side. And over on the right-hand side, you're just going to say x is equal to positive 3x plus 4. Just drop the absolute values. And now to solve this, you're going to add 3x to both sides because you got to get rid of that negative 3x. So when you add 3x to x, you're going to get 4x. And 4x is equal to drop down the negative 4, divide by 4, and you're going to get x equals negative 1. So there's one potential answer. Or what? You're going to subtract 3x from each side to get rid of that 3x over here. X minus 3x is negative 2x. And now negative 2x equals 4, so you're going to divide both sides by negative 2, and you get x equals -2. So you've got two potential answers, and they're not answers until we check them. And remember, you have to check in the original equation, which is what's typed here. So let's check x equals -1 first. So does the absolute value of -1 minus 4 equal 3 times -1? You've got to put it in both places. Absolute value of -1 is 1. 1 minus 4, does that equal 3 times -1, which is -3? Well, yes, it does, because 1 minus 4 is -3. So -3 equals -3. So that checks. Now x equals -1 is one of the solutions. Now let's check x equals -2 in the original equation. So you have the absolute value of -2 minus 4. Does that equal 3 times -2? These substitutions here. Absolute value of -2 is 2. Does 2 minus 4 equal -6? Well, 2 minus 4 is -2. And does -2 equal -6? No, this does not check. So you're going to put in DNC in there, does not check, which means x equals -2 is not a solution. It doesn't check. So x equals 1 is really the only solution. And we're going to talk about these kind of solutions that we got algebraically. We got this done correctly over here. But then when we go try it in the original equation, it doesn't check. So we'll talk about that on the next page. Now this page 3 says on your own. So it would be a good idea if you shut off the video and tried to do these 3 problems on your own. And then you can go ahead and turn the video on and see if you got these right. So go ahead, turn off the video, get through these 3 problems on your own. I'm sure you'll all do that for me. And then we'll see if you got these problems right. All right, so what we're going to do is isolate the absolute value here. So you're going to divide both sides by 2 to get rid of that 2. And 10 divided by 2 is 5. So you have the absolute value of 5x minus 5 is equal to 5. And now you're going to branch into left and right. On the left-hand side, it says 5x minus 5 equals -5. Negate that part. On the right-hand side, it says 5x minus 5 equals +5. So let's figure this out. You're going to add 5 to both sides. And this says 5x equals -5, and 5 is 0. So x equals 0 when you divide both sides by 5. The other potential answer, when you're adding 5 to 5, you get 10, and this says 5x, that cancels out, equals 10. So x equals 2. So 0 or 2 are the two answers. Let's check them. So does 2 times the absolute value of 5 times 0 minus 5, absolute value, does that equal 10? Well, does 2 times the absolute value, this is 0 minus 5, which is -5. And the absolute value of -5 is 5. So does 2 times 5 equal 10? Yes, 10 equals 10. So x equals 0 is one of the answers. The next one we're going to check is x equals 2. This was check x equals 0. Let's check x equals 2. So now we're going to put into the original equation 2 times the absolute value of 5 times 2 minus 5. Does that equal 10? So does 2 times the absolute value of 5 times 2 is 10 minus 5, which is 5. And the absolute value of 5 is 5. So does 2 times 5 equal 10? Yes, 10 equals 10. So that one checks also. So 0 or 2 are the two answers to this problem. In the next one, we have to isolate this by subtracting 4 from each side. So this says the absolute value of 3x is equal to x minus 4. On the left-hand side, 3x equals, now you have to negate this whole thing, so that should say -x plus 4. And over on the right-hand side, you keep it the same as x minus 4, just drop the bars. So to solve this, you're going to add x to both sides. 3x plus x is 4x. 4x equals 4. Divide both sides by 4, x equals 1. On the other side, you're going to subtract x from each side. So 3x minus x is 2x. 2x equals, that cancels, negative 4. So when you divide both sides by 2, x equals negative 2. Now let's check these answers, and you're going to see something interesting here. Checking in the original equation, let's check x equals 1. Does the absolute value of 3 times 1 plus 4 equal 1? Well, the absolute value of 3 times 1 is 3. Does 3 plus 4 equal 1? Does 7 equal 1? No, this does not check. So x equals 1 is not a solution. The next thing we're going to do is check x equals negative 2. So let's check x equals negative 2 over here. Putting it in the original equation, does the absolute value of 3 times negative 2 plus 4 equal negative 2? Absolute value of negative 6 plus 4 equal negative 2? Well, the absolute value of negative 6 is 6. Does 6 plus 4 equal negative 2? No. 10 does not equal negative 2. This does not check either. So both of these solutions that we came up with a valid set of algebraic steps, neither of them checked. So there is no solution because neither of these checked. And sometimes that happens. Now in this problem, you're going to subtract 20 from each side because you have to isolate just like you did in number 2 to get rid of that 20. So absolute value of 2x plus 7, 15 minus 20 is negative 5. So you're going to do 2 branches. Does 2x plus 7 equal positive 5? And 2x plus 7 equal negative 5. So you're going to subtract 7 from each side, and you get 2x equals negative 2, and x equals negative 1. Or, subtracting 7 from negative 5, you're going to get negative 12. And if you divide both sides by 2, x equals negative 6. So negative 1 and negative 6 are 2 potential answers. Let's check. Let's check x equals negative 1. From the original equation, 2 times negative 1 plus 7 plus 20, does that equal 15? Well, this is 2. This is a negative 2 plus 7 plus 20. Does that equal 15? Well, negative 2 plus 7 is 5, which says, does 5 plus 20 equal 15? No, 25 does not equal 15, so this does not check. Over here, we're going to check x equals negative 6. And there's the absolute value of 2 times negative 6 plus 7 plus 20. Does that equal 15? 2 times negative 6 is negative 12 plus 7 plus 20. Does that equal 15? Well, this is negative 5 inside the absolute values. And this says 5 plus 20 equals 15. Well, again, we've got 25 equaling 15. No, that does not check either. So again, we have 2 solutions that we came up with valid algebraic method. Oops. But what you see is that there is, again, no solution because neither one of those checked. And then the last thing I'm going to wrap up with is what is different about number 3? Well, the difference between number 3 and the other ones is you have the absolute value of something equaling a negative number. After you isolate this, the absolute value of 2x plus 7 equals negative 5. So that's different because you've never dealt with that before. All of your absolute values have equaled a positive number. And what can't an absolute value equation be equal to? If you remember way back from page 1, it can't be equal to a negative number. Why not? Because the distance from 0, a distance, can never be negative. Remember, a distance from 0 is what absolute value means. So because a distance can't be negative. So here's a new vocabulary word for you. Probably you might have heard it before in Algebra 1, but maybe not. This is really important. That's why there's a big fat star here. There's something called an extraneous solution or an extraneous root. And an extraneous root is a root that's introduced into an equation in the process of solving another equation. So what we've done here is we've introduced a couple of solutions in there, but it is not the solution of the original equation. Like when we were doing all this algebra here, we introduced these roots into our equation. We thought -1, -6, or +1, -2 were solutions, but then when we checked them in the original equation, they didn't check. So what these are called, when something does not check, these are called extraneous solutions. So when we say it's not a solution, they're called extraneous, and a lot of times we just mark it with an EXT. EXT stands for extraneous. So we have two extraneous solutions here. -2 is extraneous. It's not a solution, it's extraneous. And then back on page 2, if you remember that last example that we did on the previous page, we had x equals -2 was not a solution. That's also extraneous. So that's it for today, and we're going to be practicing these absolute value equations in class tomorrow. So we'll see you tomorrow. Have a good night.